Section 5.3, solving polynomial equations. We are going to solve by factoring. Again, we're skipping the graphing portion. That is on the calculators, which we don't have right now. So the questions will just be standard polynomial things. Sometimes they'll all be on one side, sometimes they'll be on two. So you kind of have to just pay attention where they are. The first thing you're going to do is get everything on the same side in descending order, which is standard form. So 2x cubed is the highest exponent. I'm going to list that one first, and I'm going to bring everything to the left. The squared is second, which is already there. And I'm going to subtract 3x to that left side. Okay, I don't know why it leaves that box, but anyway. Then we're going to factor out as much as we possibly can. So looking at the numbers, do the numbers have any relationship to each other? 2, 5, and 3, can't take anything out. But can we take any x's out? Yes. How many? 1x. So we're going to put an x on the outside. I already lost my marker, just a second. We might have to start over. Okay, there it's back. Okay, so we have an x. So how many are left? 2, and then 1, and then none. So what you're going to do is, the x is fine. I noticed on the quiz that some people, when they factored out the x, they didn't keep writing it. Anything that you factor out, leave it on the left, especially if you're just factoring or solving. You need them both. So leave it on the outside. Then you look at the inside and you go, okay, do I know factors of -3 that add up to -5? Probably not. So we're going to swing this, but I'm going to leave that x right now, and I'm going to come back to it in a minute. So, yep.
So at the beginning, before you took out that x from the -3,
yep.
You always look first to see if you can do a number?
Yep. It makes the factoring a lot easier. Not that it's not doable, because you don't have to, but I think it makes it easier and the number's smaller. Okay. So you might have, because that one that you did, the numbers were so big, had you taken a number out, it would have been a lot smaller and a lot, you probably could have done it without all that extra work. Okay, so we are going to swing the 2, and then we'll swing it back at the end. So I'm going to just keep writing the x, even though it has nothing to do with what we're doing right now. So that makes x squared minus 5x minus 6. And then we're going to do factors of -6 that add up to -5. What are those? We have to have one of each sign, so it can't be 3 and 2. 6 and 5. So we'll go -6. Positive, or did I say 6 and 5? Yeah. I meant 6 and 1 that add up to -5. So then it looks like we're done, and you want to go x equals 0, x equals 6, x equals -1, but we swung that 2 over, and now we have to undo that. So just be careful. If you swing the 2, circle it, highlight it, so that you remember to do it at the end. So now we are going to divide by that 2. And it's only the ones in the parentheses. It doesn't have anything to do with that x that was on the outside. Then we simplify each set. So we have x minus 3, and we'd have x plus 1/2. So we swing that 2 back out there, 2x plus 1. And we still haven't solved yet, so now we set each part equal to 0. One of our answers is 0. X minus 3 equals 0 gives me x equals 3. And then 2x plus 1 equals 0. We would subtract 1 and divide by 2, so x would be -1/2. So nothing too out of the ordinary, right? Now again, on that last one, I subtracted 1 and divide by 2. I just kind of did it in my head. You can show those steps if you need to. But could we have done this one without me even saying it? Yeah. So a lot of them will be just like this. But what happens when we have something funky in the parenthesis, then that's the one that we're kind of leading up to. Okay, so on this one, I'm going to get everything on the same side. 6x cubed would go in the middle. So what kind of a number? 3, 6, and 12 are kind of related. What kind of a number can I take out? I'd go 3, because the 2 doesn't come out of the 3. So, and then how many x's? 2. So what we're going to be doing is divide the numbers, subtract the exponents, okay? So 3 divided by 3 gives you 1. X to the 4, when you divide a x to the 2 out of there, you get 2 left because 4 minus 2 is 2. For the next one, I'm going to divide -6 and 3, and I get -2. And again, I subtract the exponents, and I get 1. You can put a 1. I'm not going to leave it a 1 like that. And then 12 divided by 3 gives me 4, and I took the variable out. 2 minus 2 gives you 0. What is something to the 0 power? 1. It's 1. Okay, so way back in algebra, when you do 1 to the 0, you get 1. Okay, and you can check that on the calculator. The only thing is when you do variables, you can't check it on the calculator. That's why I kind of went back to that.
So did we take out 2 x's and divided by 3?
Yes. So you subtract.
Why is the 3x still up there?
Because you have to hold it there. Like whatever you do, whatever you take out, you have to hold it on the outside. Otherwise, it'll throw those last answers off. And you'll be like missing an answer. Okay, so now we look at the parentheses. Can we do factors of 4 that add up to -2? We would have 2 and 2, which then gives me 0. Or we could have 4 and 1, which gives me 3 or 5, depending on what the signs are. So it doesn't look promising right now. So what I'm going to do is I'm just going to work on this part, and we're going to just put this part into the quadratic formula. Okay, so anytime you have something that you don't know how to factor, even if it's something that you can factor, remember the quadratic gives you the answers. So it doesn't matter if it's one that you do know or the one that you don't know. If you're not a very good factorer, you can always put it in the quadratic. So we're going to put this in there. The 3x squared is still there. I'm not worried about that yet. I'm going to put a box around it so we don't forget about it. Okay, so let's not forget that. And, okay. So I'm going to do it off to the side. X equals -b, which would be 2, plus or minus. B squared would be a -2 times a -2. I'm just going to put a 4. I tend to get signs wrong sometimes when I put all those negative signs in there, so I just do them in my head. So then it's -4 times A, which is 1, times C, which is 4. And then I have a 2 times 1 on the bottom. So under the square root, I have a 4 minus 16, 4 plus 16, right? Which is 20, divided by 2. I don't remember. I just did this one, and I don't remember getting 20. Yeah. Oh, I put -4. I have it written right. I just did it wrong. So 4 minus 4 times 1 times 4. I took that last 4 as a -4. So this should be -12. I knew I needed to get a negative number there. Okay, so what do we do with the negative?
I have a question.
Yep.
Where did you get the first 4 in the square root box?
-2 times -2, because it's b squared. So I would take this number right here and square it. Okay. And you can certainly have that quadratic formula sitting on top of your paper somewhere if you don't know it yet. I know it in my head, so I don't have to use it, but definitely have it kind of as a reference there. So I'm going to turn that negative into an I, and I'm going to put it out in the front there. And then I'm going to start reducing stuff.
You can put the I behind it, right?
Yep. Just know that the I is not under the square root anymore, even though sometimes it looks like it is, it's not. Okay. Okay, remember square root of -1 is an I. We did that, what, a few days ago? I can't remember how many. Now we start reducing. So 2 plus or minus I. Now 12 is factor 12, I'm thinking 4 times 3. If you go by 2, you have to do it again. I just think of perfect squares that go in there, but you can do a factor tree. You'd have to circle things that have 2's, like 2 2's, 2 3's, 2 4's, 2 whatevers. So my 4 is a perfect square. So what is the square root of 4? That comes out. And the 3 is not a perfect square, so that stays in. So if you have trouble simplifying the square roots, for sure get it to the point where you have an I with it, and then do what you can. But that, again, is a simplifying thing, not a whole, whole something wrong. Now we have to divide those 2's out of there. So this 2 goes out as well as that one. Now, when you're dividing, you want to be careful, because if this one only comes out of here, you don't want to just cancel those 2 out and not have any denominator. They both have to have it in order for you to cancel it out. But what is 2 divided by 2? 1. So I'm going to go 1 plus or minus I square root 3.
Why don't we have to put the 1 under and in front of the 3?
You can. That's not a big deal. It just looks like a fraction when really it's not. Okay. Okay, so here's where we need to start doing answers. Now, I'm not going to write this thing as a factor because it looks really ugly. Eventually we will, but right now we're just solving. So we have solved that second part, which gives us those answers. Okay, I'm going to just circle that. For this section, I'm not going to make you write them twice. One with a plus, one with a minus. Just know that that's 2 answers. What does this one give me? 0. So you go 3x squared equals 0. You divide by 3. You get x squared equals 0. And square root of 0 is 0. Okay, so that does give you answers on the outside. You don't do 3 equals 0 and x squared equals 0. It's one thing together. So in this section, you can do the plus or minus together if you want to. If it makes more sense to separate them, go ahead. Yep, I'll leave it right here. So today, you might have stuff that can be factored. You might have stuff that can't. It looks like ugly answers, but there you go. Yep.
Are you dividing it by 3 to get x squared by itself?
Yeah. And of course, you can do that in your head. I just showed you what I was doing. Some people are thinking that, maybe it's 3 and you go square root of 3. Yep.
Would you have to put the 1 in there?
The 1 plus or minus. Yep. Yep. You got to hold that place right there. She was asking for these 2 right here. When you divide those out, you do have to hold that place with a 1.
How come you don't have to put a 1 on the bottom then?
You can, but you don't have to, because what's something divided by 1? Whatever it is.
Whatever,
Yeah. So if that number on the bottom ends up to be a 1, you don't have to write it. It doesn't mean that it's a 0 or anything. It just means it's dividing by 1 and it doesn't change the answer. You could also do this if you get confused and you're not sure. You could go 2 over 2 plus or minus 2i square root 3 over 2 and then do them separately and write it like that. Either case gives you 1 plus or minus I square root 3. Okay, now if one simplifies and one doesn't, that's the route you take, is that second one. But most of the time they do, but sometimes they don't. You sometimes do have fractions at the end. Okay, any questions so far?
And then how it gets to x equals 0 is always
Yeah. Basically, when you have a letter outside that's by itself, it's always going to give you 0. It could be a cube, it could be a 4, it could be whatever it is. It's always going to be 0. You don't have to really show all of this. I just kind of did it to show you how you solve and, you know, get to the answer. Okay. Now, this table, and this is only part of it because it's so big, are different ways to factor. And you don't have to write them all if you know them, but I'm not going to have you take the time to write them now. You can write them in your notes some other time. One of them is perfect squares. Like if you have a minus b squared, like here, this one. It kind of gives you what it looks like before and what it looks like when you FOIL it out. It's kind of just listed in reverse. If you have an a plus b, the quantity squared, what does it look like? You know, and it gives you an example with numbers there too. So take a look at all of these. Difference of squares we've done. If you have a squared minus b squared, remember the signs are different because there's no middle terms. The one they give you to actually practice looks kind of ugly there with difference of squares, but you could practice it with better numbers if you wanted. Do you guys remember factoring by grouping? I think you did it, but it probably was like more toward the end of the year. Do you remember the ones on the last assignment that you couldn't necessarily factor? That's what you do on those. So we're going to probably have to go through that at some point, but we're not going to do it today. So maybe tomorrow if I have time, we'll see. Sum or difference of cubes. I think you've done that as well. These are something that I remember just because I use them probably more than you. When you look at this one, if the sign right here is positive, the first parenthesis is positive, and then the one next is negative. And it's the opposite for this one because they look exactly the same except for the signs in the middle. It's a formula that you can use. So if we had like x cubed minus 2 cubed, the a would be the x, the b would be the 2, and we're going to go through that like right now. We're going to go through how that last formula works. So write those formulas down if you need them. If you don't, that's totally fine. All right, so here's more. They look the same. It's just that they might be something that we can factor in a different way. Okay, so everything on the left in descending order. Now, can't take out a number. Can we take a variable out this time? No. So this one looks different than the ones that we just did. Also, you can't just put it in the quadratic because it has 3, because the highest exponent is a 4. What's the highest exponent for the quadratic? 2. So we can't do that either. So when those things happen, you're thinking, this must be one of those weird ones that I can factor in another way. Okay, so here's what I'm going to do. When I look at x to the 4, here's what I see, and you may not see it yet, but after you do a few of these, you will. It is set up like it is something squared, okay? How about 4? 4 is also a perfect square, right? 2 times 2. So I'm going to factor this, but I'm going to break it down into those things instead of just a number. Okay, so it's going to look kind of weird right away. So I'm thinking, what is the square root of x to the 4? It is x squared times x squared. It's kind of like when you had an x squared sitting there and you take the square root of x squared and you get x and x. This one's just a bigger exponent that you have to split up. Then, let's see. And I'm not going to do the 2 times 2, but that's what I thought of initially. The only reason I'm not doing 2 times 2 because the middle terms are still there. What are factors of negative 4 that add up to 3? And the negative goes with the 4. Okay, so if I FOIL that out, I should get what I started with. So x squared times x squared is x to the 4. I'd have minus 4x squared plus 1x squared. That gives me my minus 3. And then I'd still have minus 4.
Wait, that's the sign.
Yes.
Why would you put the smaller number with the positive?
Because one has to be positive, one has to be negative. Since this one's negative in the middle, the highest one always has to be negative, whatever that sign in the middle is.
I'm so
Okay.
used to it being like on the other side.
Yeah, and you can put them wherever. You could have done -4 plus 1, doesn't matter. Okay, then x squared plus 1 is like this one. It kind of reminds me of this one. No, they don't have it on here. No, they don't have it on there. But I don't see that as being factorable at the moment. But what about x squared minus 4? X squared is a perfect square. 4 is a perfect square. This one becomes x minus 2, x plus 2. If you're not a very good, oh my gosh, this is difference of two squares, you would have to do the quadratic formula twice on this one. Okay, which is fine, it's doable, but definitely recognizing those things helps. Now, I did this one, but I have not done that one yet. I need to get down to answers there, so the only thing I can do is do the quadratic at this point. So you'll probably have to do the quadratic quite often today. What would my middle term be on this one? 0x, yep. Okay, so now I'm going to change colors so it stands out a little more. X equals... -0 is just 0. 0 squared, again, -0 is just 0. -4 times 1 times 1. And then 2 times 1 on the bottom. This one's going to simplify out pretty quickly because we don't have that first number anymore. Because 0 is just 0, so I don't have to write it. You can write it if you want to. 0 divided by 2 is just 0. So I really have plus or minus square root -4 over 2. So again, the only thing I did there is 0 divided by 2 is 0, so I just got rid of that. I need to turn the negative into an I, either behind it or ahead of it. And then what's the square root of 4? 2. So I have plus or minus 2i over 2. And what does that become? 1i. Yep, so you get plus or minus I. So here's my answers. This one gives me x equals 2. This one gives me x equals -2. And I also have plus or minus I. You could do plus or minus 2, plus or minus I if you wanted. But you can list them all out too. So you could do 2, -2, I, -I, or you can put the pluses and minuses in so you don't have to write quite as much. Now, the next one is the one that I want to look at for sure because it's the cube, difference of two cubes, probably. Okay, so with this one, get everything on the left. And looks pretty simple. You have to, it says solve by factoring, so you don't just want to go add 1 and cube root both sides. That's not going to give you everything that you need, okay? So it says by factoring. So here's the formula just so you guys can see it. They have A's and B's. Okay, and that's just looking at that formula sheet that I just did. Okay, so the way that you use the formula is this. I'm going to put mine directly underneath it so you can see where my numbers are coming from. Now, what is, 1 is a perfect cube, right? 1 times 1 times 1. Okay, so I'm going to put it as 1 cubed. So,
is 1 then b and x cubed is a?
yes, just x. X is a. Okay, so when you guys are using this, it has to kind of look the same. So what would it be if this was an 8 here? What's the cube root of 8? 2, like 2 times 2 times 2. So a would be x and b would be 2. Okay, so on your calculators, you have a cube root, don't you? Use that, Okay, so put in 8. Cube root of 8 gives you 2. So you're looking for something that something times something times something is that number. We're not doing 8. Yeah, I want to do a cube root of 8. That's not what we're doing now, but just what? Oh, there's a cube root. Go, let me look. I can't remember where it's at. Yep. Go to the caret. It's like diagonal from the 7. And it says x and then it has a root. If you put in 3 first and then hit that one, it'll be like cube root. It puts that 3 into the x and then you can put your 8 and you should get 2.
I got 6,000. I got 2.
Okay. What did you get?
I got 2. Oh.
I got 6,000.
Okay, 6,000. So watch. You go 3 second. Oh, I didn't know I had first second.
Oh, you did the caret thing. Yeah. Paige, that's what you did too. Okay.
Yeah, I went like that.
Okay, everybody get it?
Yeah.
So you have to hit 3, which puts it in for the x, but you have to hit second so it does that upper thing, not the caret. Okay, so anytime you can use a cube root there. It can be any number. You could do a 4th root if you needed. Okay, so what this means is anywhere there is an a, I'm going to put an x. Anywhere there is a b, I'm going to put a 1. No exponents, just those things. Okay?
You don't have to worry about the negative one. Like the negative from.
No, because the formula takes care of that for you. Yep.
So what if it's like x squared or a squared? Then you just do x squared.
It probably won't be right away. I mean, that would have to be like an a to the 6.
But what about like in the formula?
Oh, I'll show you. Yep. So we're going to put it in the formula. So the first parenthesis says a minus b. So that means x minus 1. So I'm just replacing my a with an x and my b with a 1. And now, Ariel, this is your question right here, right?
Yeah.
Okay, so if I put an x in for the a, it becomes whatever it is squared. So that exponent stays with it. So whatever the a is, I take x times x, which is x squared.
So the exponents really don't matter when you put it into this equation. Like the exponent it had you just
Stays.
have to follow the exponent
Yes.
in the equation.
Yes, yes. The next one says a times b. So what's a times b? X. And then what is b squared then? 1. 1 times 1. That is the factored form that we need. Okay? Then we need to solve each of those.
Why can't we just leave then the minus 1 cubed? Why can't we just leave that 1? Because 1 times 1 times 1 is still 1.
Because we need the answers from here. We're not just getting like 1. You know, that would just give you 1. Okay. So I'm going to put this back over here now because we've now factored it. I kind of always do the factoring off to the side. This one, we can get an answer, right? What is it?
This is what I know the question.
Yep. X equals 1.
How is B1 like when up in the equation is negative 1?
Notice how on that sheet there's 2 equations. One has a plus in it. And look at that big chart on in your book. There's 2 formulas. There's a sum of 2 cubes and there's a difference of 2 cubes. What you need to pay attention to is which sign you have. And whatever sign you have, you follow those signs exactly. Don't change them. Okay, so it doesn't matter that there's a minus here because this formula takes care of all of that. Don't change them, just leave them. Don't think too hard. So x minus 1 gives you 1. Now we have to do the quadratic on the rest. So it's kind of a lot going on because you always generally will have to do the quadratic today. Okay, so negative b is negative 1. B squared is 1. 4 times 1 times 1. And 2 times 1 on the bottom. Yep. Okay, 1 minus 4 would be negative 3. 2 on the bottom. I'm going to change this negative into an I. I cannot reduce any of that. Looks ugly. So I left it like that. This time we didn't have any numbers that had 2's in them up here, so I separated them just to make it look a little bit nicer. But that is the answer, and there's 2 there. One of them would be negative half plus I squared 3 over 2. The other would be negative minus. Yep.
Could you just leave the negative 1 plus minus I squared 3 over 2?
You can. It just looks, you don't have to change them and separate them if you don't want to. I would probably leave it like that, but it looks kind of funky. I don't know. Okay. So here we go. You got to write this down before you leave. Yep.